Welcome back. We're going to continue our discussion on transforming a line structure to a Newman. Now, this particular video has nothing to do with RNS, okay? And the whole idea of Newman projection might take a couple of seconds, maybe a whole minute for you to sink in because this is not something you have ever seen all the way from 170 to 330, okay? So stay patient. The video is not going to be long. It's easy. Just just understand what it is I'm trying to do. And I will do my best to explain myself clearly so I'm not leaving any loose ends or trying to rush through or anything. Even at a normal pace, this video is going to be very, very simple because all we are doing is simply transforming a structure from one form to the other. And going from line to Newman, we do not have to do RNS. So now what is this Newman? Now, there may be a technical definition in the book. I didn't even look into it because I have come to appreciate this concept and I have found a definition that works the best because people always wonder why we do something, and I gave some rationale for when we did Fisher and Line. Newman, the way I see it, is kind of determining probability structures very easily. You can draw multiple structures very, very quickly. And from that, we can actually estimate which structure would be the most stable. And there's a specific video dedicated to energy diagram using Newman projection, and we will get to that. But the way I see a short definition of Newman is probability of structures. That would be my definition of what a Newman projection does. And with that, we can say this structure is going to be the least stable. This is somewhere in between. This is somewhere in between the previous two and things of that nature. So you're all familiar with the line structure. Okay. So we're going to convert this to a Newman. So assign number to all carbons. It doesn't matter left or right. However, for convenience, since like I've done before, I'm going to be assigning from left to right. And I suggest you do the same. Second, you do not have to determine configuration. That's the beauty of it. You don't have to do whether it's R and S. You will be specified to draw the Newman projection. You can't just draw Newman projection anywhere you like. It normally makes sense if somebody tells you which two carbons you're interested in. Remember, I said two particular carbons. You would always be specified. And again, I haven't even thought of how I'm going to write a test question at this point. Okay, so don't ask me how I'm going to do this on the test. We will get there eventually. Okay, so for convenience, like I said, I am going to start numbering from this side. So 1, 2, 3, and 4. And I'm going to say between 2 and 3. Those are the two carbons we are going to pick to draw our Newman projection. Okay, now what is exactly this Newman projection? Newman projection is basically like 2 points inside which a circle is sandwiched. That's what it looks like. Okay, so because there will be 3 points coming out of 2 and 3 points coming out of 3. You need to know what those 3 points are. Okay, so I'm going to draw one circle, okay, and of which I'm going to draw one dot in the middle. You only see the one dot all the time. Okay, from that dot I'm going to draw 3 lines. Okay, and then I will draw 3 more lines, either one back like this. Okay, don't get too caught up in this. Okay, now let's focus on the front circle. I'm going to call this 2. So basically that's carbon 2, and then the bond is what is connecting 2 to what is in the back is 3. So this is this portion right here. That is what essentially the circle is. Okay, basically we're looking at a molecule, carbon 2 and 3 sandwiched. Okay, So 3 is behind the circle. So from 2, you are wondering, well, what goes on here in these endpoints? Well, if you look at it from, I am going to look at it from this side because that's where I start numbering, right? To me, the hydrogen is in the front, right? So I am going to look at this molecule from this way. So this is 2. Don't draw it here. That's for 3. Okay, this is for 2. So the hydrogen goes, because I'm coming from this way, remember the black closed wedge is coming towards you and this is going away from you, right? So the hydrogen goes here and the OH goes here. Because this is the way I'm viewing, to me, when I view from here, the black is what I'm viewing, this is in the back. So this, the one that's not chiral always goes at the top. That's the way I've always done it and it works magic. So that's what CH2OH, right? Now this is not going to be everybody's cup of tea right away, but it will be everybody's cup of tea eventually. Okay, now let's go to 3. Again, 3, it's got the C double bond OH, so that's always in, I always put the non-chiral in the vertical position. So that's where this carbon is, okay? This endpoint is where this carbon is. Again, I'm looking at it from this way. Again, still I'm looking this way. The hydrogen is towards me and the OH is away from me. Now you could have drawn, I could have drawn it on this side or this side, it doesn't matter. Really doesn't matter, okay? So this is part of the back, okay? So sorry about that mess. Could have kept it on this side, okay? So this is one of the million combinations possible. Now I am not going to go into the combinations on this because I want to reserve this for the energy diagram where we learn how to do the combinations, okay? Now I think that's all I had to say on this. I'm going to do one more problem, okay, just to help you draw Newman structures, okay? This is very, very simple. You may be a little bit lost at this point, but just stop the video and rewind it one more time, okay? I did not speak in a new language. I spoke in a language that I know and you all know. So it's going to be very simple if you actually watch it one more time, okay? Basically, we are looking at the molecule from carbon 2 perspective. So 2 is in the front, 3 is in the back, okay? Essentially, we're compressing a 3D into a 2D from looking only one angle. That's what we've done. All right, so I'm going to stop this here. I'm going to come back and do one more practice problem, and then I will leave you with 3 more problems to practice on your own. All right, so stay tuned.